So this is the 2025 paper, October, November. This is version 2 and 2. We're going to start with the paper, right? Uh, the first question, right? What happens to the volume of a fixed mass of a gas when the temperature is increased or the pressure is decreased, right? So we're talking about the volume. What is happening to the volume? If the temperature is increased, then the volume should increase because it's a fixed mass, and if the pressure is decreased, that should also increase the volume. So D is your option, right? So keep in mind we have pressure and temperature to be worried about, right? Okay, next. uh, the diagram shows the heating curve of a substance from, right, this is from P to Q, Q to R, and all this, between which two points do the particles of the substance change from being in fixed positions, right, to being mobile. That means that is solid and this is going to be liquid, right? So when do they change from solid to liquid, between which 2 points? Keep in mind that's going to be between Q and R, right? Remember, the state changes when the temperature is not changing, right? So I'm going to take the flat ones. These peaks are not included. So it either could be S or T, that would be from liquid to gas, right? So it's going to be Q and R, option B for us. Okay. Stop me if any question is not clear, then I can explain in detail as well, right? The investigation, the student investigates the diffusion of ammonia gas, which is a base, right, with the hydrogen chloride, which is an acid, right? I always mark extra information whenever it's there. Right? Two sets of operators set up as shown in this at room temperature, right? Source of ammonia at this, and damp litmus paper, right? Source of hydrogen chloride and a damp blue litmus paper, right? The red litmus paper in apparatus 1 changes color after 30 seconds, right? How long does it take for the damp litmus blue paper in the apparatus 2 to change color? Now keep in mind, if we talk about their masses, right? Since we're talking about diffusion, how fast things can move, right? How fast the fumes can move. So, then over here, I have 14 plus 3, which is 17 grams, right? The MR, and the MR of this is basically 36.5, right? 35.5 plus 1, right? So in other words, it's not going to be this, it's not going to be this. Damp blue litmus paper does not change color. That is irrelevant because we're talking about an acid. Acid would turn the blue into red, right? So the only option viable left is 64 seconds, right? Which row describes the element, compound, and mixtures? Elements. All the atoms are the same type, technically correct, right? So that means can be separated into new substances using chemical processes. Using chemical processes, new substances, no. Contain different atoms, no. So option C and D are already cancelled off, so we can cancel these off, right? Now out of these, A and B, compound, right? Contain different atoms chemically joined together, can be separated into new substances using chemical processes. Fair enough, right? Can be separated using physical processes, that is correct. Contain different atoms chemically joined together, that is wrong, because in mixture we have a physical combination, not a chemical. So A is your option, right? Which statement about the atoms or ions is correct? The mass number of an atom is the total number of nucleons and protons. Now remember, nucleon is already neutron plus proton, okay? So that is not correct for you, right? The electronic configuration of aluminum A plus 3 is 2, 8, and 3. Not possible because it has plus 3 charge, so it should be 2 and 8, right? Hydrogen is the only atom that has an incomplete first electron shell. Seems plausible, right? I will mark it correct if it is later, right? I'll cross off all first. Most of the volume of an atom is taken up by the nucleus. No, nucleus is infinitely small compared to the size of the atom. So C is the only viable option we have got left. Remember, in such questions, always use elimination method, right? Eliminate all the options, even though if you have found the correct one, right? Always eliminate all of them. Okay. Next one. Which two values are used to calculate the relative atomic mass of a sample of boron, right? Relative atomic mass. Total number of isotopes, we need one, right? Total number of isotopes, not really. Relative abundance of this, remember the relative atomic mass formula, right? That is percentage into its mass plus percentage into its mass, right? Divided by 100. That's the relative atomic mass formula. So total number of atoms, that's not important for us. Neither is this, right? Uh, the relative abundance of each of the sample and the relative mass of each boron. So B, right there for you. This and total, again wrong, right? Total number of isotopes, again wrong, right? This is correct and this is correct. So the only option viable over here is B for us. Okay, again I use elimination. Remember, in Cambridge papers, for chemistry especially, elimination is the best method you can crack any question, right? Which statement describes the structure of sodium chloride, right? Sodium chloride, again, it's an ionic compound, right? It's a salt. So salts are ionic compounds. A lattice of alternating positive and negative ions, correct, right? A lattice of positive ions surrounded by a sea of delocalized, that would be a metal. A mixture of sodium and chloride atoms? No, mixture means physical, right? A regular lattice of sodium and chlorine atoms? No, they're not atoms, they're ions, right? So A is your answer, right? Again, elimination, right? Even though I knew the first answer, right? Graphite and diamond are both forms of element carbon. Which row shows the number of other carbon atoms that each carbon atom is covalently bonded with, right? So in diamond, we have this structure, and in graphite we have this structure, right? So in graphite we've got 3, in diamond we've got 4, so that's going to be B for us, right? Clarified? This is how their structures are divided, right? The fourth one is the you can say the superficial bond, or the delocalized electrons stay in between, right? The conduction electrons for the graphite. This is diamond, right? This is diamond for you. Diamond and graphite. Okay, which row describes the structure and bonding in cobalt, right? The structure in cobalt, it's a metal, so keep in mind it's gonna be giant, it's not going to be simple. So simple is out because metals are large structures, and it's not going to be ionic, it's going to be metallic. So the C, right? Since it's a metal, that's going to be metallic bond, right? The equation for the combustion of ethanol is shown, right? This is the combustion, right? This is complete combustion because it's CO2. The relative molecular mass mr of ethanol is 46, right? Which statement about the reaction is correct? 4.6 gram of ethanol produces 4.4 grams of carbon dioxide. Now for this, we'll have to use the mRs, right? So first we need to know how much moles are there for this, right? 46 gives you the idea. 4.6 divided by 46 is going to be 0.1 moles of ethanol, right? Since I've got 1 ratio 2, right? And keep in mind, we have to check the other ones, right? So it is 1 ratio 2 for this. So from this, I can tell the CO2 that is being produced is going to be 44, right? So 44 into 0.1 is 4.4, seems correct, right? Because but over here I have 1 ratio 2, so that should be now 8.8 grams. So that's going to be incorrect actually, right? 9.292 grams of this, right? Again, they're multiples of each other, so that's going to be zero point 0.2 mole, right, of ethanol, and 88 grams of this, right? So if you look at this, and 108 grams, since the carbon dioxide is not matching, we have zero point 0.2 moles, and 0 0.2 moles into 44 is going to be 0.2 into 44 is 8.8 grams, right? Sorry, it is 2 moles, right? So this seems correct. Now let's check the water, right? Water MR is 18. Again, it is 3 moles, right? 1 ratio 3, right? So it is, since 2 moles, so 2 into 1 to 3, right? So water will be 3 moles. So 18 into 3. 18 into 3 is 54 grams, which is wrong. It should be 54 grams. That's going to be wrong, right? This is 8.8 grams for this. I'm measuring from this, right? So both these options are now correct. 138 grams of ethanol, right? 138 divided by 46, that's going to be 3 moles, right? So 3 mole is there. Ethanol reacts with 32 grams of oxygen, right? Now keep in mind, we have 1 ratio 3, so that's not possible. We need actually how many moles of oxygen? 9 mole, and 9 mole of oxygen means 9 into 32, right? Okay, so 9 into 32 is 288 grams, so that's also wrong. 288 grams, right? 184 grams of this produces this much of the water, so 184 divided by 46, that's going to be 4 mole, right? And 216 divided by 18 is 12 moles, right? So if you look at their ratio, 4 ratio 12 is basically 1 ratio 3, which satisfies our equation So D is our option, right? So this question was a very time taking process. You have to calculate each and every one. Don't try to go too blunt. Remember, there are about 3 MCQs in the paper which are going to take a lot more than 1 minute, right? So they are time taking. You can keep these questions for the end. I'm just gonna go in sequence. Okay, the compound contains 40% this, right? The relative formula is this. So let's build this, right? 40 ratio 6.7 ratio 53.3 divided by 12 divided by 1 divided by 16, right? We're gonna get the ratios over here, right? 40 divided by 12, that is 3.33, ratio 6.7, ratio 53.3 divided by 16, right? That is also 3.33. So that's gonna be 1 ratio 2 ratio 1, right? So the empirical formula is CH2O, right? So these two options are gone anyway, right? So we can cross them off. And then since the MR is 60, let's take the empirical formula mass, right? Empirical formula mass. And that's going to be 12 plus 2 plus 16, right? So 12 plus 2 plus 16 is 30, right? Since it is 60, that means I need to multiply the empirical formula by 2. So my option is going to be option B. That's the empirical formula, and that's going to be the molecular formula because I have to multiply this whole thing by 2, right? Again, this is 60 by 30, right? Molecular formula mass by empirical formula mass. MR over EFM, right? That gives you the multiplier, which you multiply with the empirical formula to find the molecular formula over here. Clarified? Okay. Next one, the hydrogen oxygen fuel cells are used in electric cars. 3 statements about these fuel cells are listed. The process in the cell is called electrolysis. Yes, it is, right? The water is broken down into cell in the cell to produce hydrogen and oxygen and electricity. That is correct, right? Water is the only chemical product formed in the reaction, right? Water is the only chemical product formed in the reaction. Now keep in mind, there's a difference, right? When you do electrolysis, then you break it down into hydrogen and this, right? Now, if you take fuel cell, we actually react hydrogen and oxygen and make water out of it and get electricity. So technically, our option 1 and 2 are wrong. So 3 is the only one correct about the fuel cell, right? These two options are correct when we are doing electrolysis of H2O. H2O into H2 plus O2. But the fuel cell actually works in reverse. We react these two together to make water and get electrons out of it, right? So only 3 is correct. Clarified? Again, technically they're all right, but for our case of the oxygen fuel cell, as the name suggests, hydrogen oxygen fuel cell, that means your reactants are hydrogen and oxygen. So why would the water be broken down? As said, it was correct technically, right? And the process electrolysis, that is also right. But electrolysis is the breakdown. This is reaction, right? So we react them together and we do reverse of the electrolysis. Okay. So the option 3 is only one correct, right? This also gives you the idea, if 1 and 2 are correct, then 3 should be also correct, right? If 1 and 3 were correct, then 2 should also been correct. Only 2 is not possible because 1 is also correct. So I have eliminated all 3. Even if I don't know the answer, I could have gone to this immediately by knowing these statements alone, if I don't know how the fuel cell works. Okay. But keep in mind, the fuel cell works like this, right? Reacts and gives you water and gives you electrons. It's the reverse of electrolysis of water. Clarified? Okay. Next, a solution of copper 2 sulfate can be electrolyzed using copper electrodes and carbon electrodes, right? Which statement is correct? Using copper electrodes, oxygen gas forms at the anode, right? If you use copper electrodes. Now, for this, I told you immediately make quick solution, right? So you have Cu plus 2 and SO4 minus 2, right? Obviously, the sulfate is there. Oxygen will get the preference because sulfates don't come out of the electrolyte. But the problem is, since you have the copper electrodes, one copper electrode will dissolve and the other will get the mass. So if you use copper electrodes, no gas will be formed, right? It's just the electrolysis, plating will start happening, right? This is electroplating. Using copper electrodes, copper atoms lose electrons at the anode, right? Anode is basically the positive one, right? So why would the copper electrodes lose electrons at the positive, right? And then the gain at this, so makes it plausible, right? Makes sense. Using carbon electrodes, copper metal forms at cathode. No, it will not, because the negative we will get the Cu positive ions, right, to come to this, right? A copper metal will be formed again. Carbon electrodes does make sense a little bit, right? Using carbon electrodes, copper ions gain electrodes at the cathode, right? Copper ions gain electrodes at the cathode, right? Uh, that is also correct, right? Because they will receive the electrons. So I think 2, 3, and 4 are correct, right? So keep in mind, just put the P's and the crosses. P means plausible, that it makes sense, may be correct, right? And then you can verify using these options that which one matches your description. 3 were plausible, so 2, 3, 4 is an option available over here. I'm just going to pick that up, right, without further verification, right? Next, the equation for the combustion of hydrazine. Hydrazine is rocket fuel, right? N2H2 is shown, right? This is the hydrazine in which we get nitrogen, N2, and this H2O, right? What is the overall enthalpy change of the combustion of reaction? Again, this is another time taking question. I suggest you do it at the end, right? Do the statement once first that do not require much time. I'm just going to go in sequence, right? So I see how many of the hydrogen NH bonds are broken, right? How many of those are broken down? 4 of them, right? So into 4, right? I simply put the multipliers here, right, for the actual paper. And if you look at the N double bond, one of this is broken, right? So these are positive. Keep in mind we're breaking these, right? And then we have the NH3 being formed. That is only one. That's going to be negative value, right? And how many of the OH are forming? 1 and 2. And keep in mind we have a multiplier of 2 as well. So 2 2s are 4, right? That's going to be 4 OH bonds forming, and that's going to be a negative value, right? And the O double bond is broken down. That is again one bond being broken, and that's going to be a positive value, right? So simply multiply them and take the delta H as a sum, right? So we have 391 multiplied by 4, that is going to be plus 1564. Remember, I always put the symbols over, right? 409, that's going to be plus 409, and then it's going to be plus 496, right? For this one, it's going to be minus 944, right? And then 4 into 463, that's going to be minus 1852, right? So if I sum them up, I can get the value, right? So 1564 plus 409 plus 496, right? That's 2000, right? Plus 2469 minus how much it is? 944 uh, and this 1852, right? That's gonna be minus 2 this, right? So 2469 minus 2796 is equal to minus 327 kilojoules per mole, right? And that's going to be negative because that's a negative H, right? So delta H is minus 327, right? So that's our answer. Okay, moving on. Dissolving ammonium chloride, right? Ammonium chloride NH4Cl, right, in water is an endothermic reaction, right? So delta H is positive, right? Which shows the energy change and the temperature change of the mixture during dissolving of ammonia, right? So it is a delta H positive, so the energy is absorbed. These two are cancelled, right? So I'm just going to cancel them off. And then the delta H is positive. That means the temperature should go down. So A is our option. Energy is absorbed and the temperature should decrease. The test tube will become colder, right, if I dissolve this. Okay. Next, aqueous sodium thiosulfate reacts with dilute hydrochloric acid to form yellow precipitate of sulfur, right? Yellow precipitate, right? This we get sodium chloride, water, S and SO2, right? The precipitate forms more quickly when the reactants are heated, right? Heating, okay? Which statement explains this observation? The reacting particles collide more frequently, right? We can say that, right? The collision between the reacting particles have more energy, that's for sure, right? Because heating gives us more kinetic energy. The activation energy of the reaction is lower. That is not possible because EA is only reduced by catalyst, right? So this option is out of the water, right? I would go with only 2 because usually temperature is not related to the frequency of collision, but I don't see an option here that lists only 2, right? That means the option 1 will also be correct, right? You get the idea. Even I can get confused as a teacher, but I again use elimination method, I can see that there is no option for only 2. That means option 1 would also be correct. So I'm just going to pick up A, right? Because 3 is wrong, 3 is wrong, and only 1 is not possible because that is for sure I know, right? So this is also wrong. Clarified how I eliminated these other options, even though I was not clear about the first one, right? Which statement about the conditions used in the Haber process and the contact process is correct? Right, the typical pressure used in Haber process is similar to that used in the this, not at all, right? This is 200 atm and that is 2 atm. That's wrong, right? The typical temperature used in the Haber process is similar to that of this. Yes, 400 to 450 for both reactions. I'm going to go for this. The Haber process uses vanadium oxide as a catalyst and contact uses iron. No, that's the opposite, right? Because if I use iron in contact process, H2SO4 will immediately dissolve iron and the catalyst would be gone, right? So we use an inert catalyst for this one, right? If you read the book, this is called inert catalyst. And iron is used for ammonia or Haber process. Reason being, ammonia is a base, so it will not affect iron at all, right? Both processes produce acidic gases. No, ammonia is a base, so that is also incorrect. So B is our only option here. Okay. The equations show that the equilibrium between nitrogen tetraoxide N2O4 and nitrogen dioxide, right? The colors of the reactant and the product are shown colorless to brown. The forward reaction is endothermic, right? Delta H is positive, right? Forward. That means backward is gonna be delta H is going to be opposite of this, right? Backwards. Which statement is not correct, right? At equilibrium, the concentration of the reactants and the products stay consistent. It is correct, so not our option, right? Keep in mind we are looking for not correct. I'm putting a tick to identify this is a correct statement, so we will have to eliminate this. At equilibrium, the rate of forward is equal to the backward reaction. That is also a correct statement, so not our answer. When the pressure is increased, a darker brown color is seen, right? If you now look at the number of moles, we have 1 here and 2 here. If you increase the pressure, that means the reaction should go backwards towards less moles, right? That means if I increase the pressure, we should get from brown to colorless rather than the other way around. So this is the incorrect option. This is our answer, right? But I'll still eliminate the last one. When the temperature is increased, dark brown color is observed. Obviously, if you increase the temperature, it will favor the forward reaction because delta H is positive. So this is also correct, not our answer, right? So C is the correct one, right? So it should get colorless rather than becoming brown if we increase the pressure here, right? What is the oxidation number of chromium in Cr2O7, right? Now Cr is 2, O is 7, minus 2 means, right, minus 2 into 7 makes it minus 14, right, minus 14. Now, and the total ion charge is minus 2, right? So in other words, out of minus 14, we are only left with minus 2 charge, right? So remember, O7 should have minus 14, but the ion as a whole has minus 2 charge. That means remaining charge is contributed out of minus 14 by chromium. That means chromium 2 ions are providing plus 12 charge, and since there are 2 atoms, each one is going to be plus 6, so the oxidation state is going to be plus 6, right? So plus 6 into 2, right? And it's going to be minus 2 into 7, right? So the total sum is minus 2 net charge, which is shown on the top of this minus, right? So remember, for any molecular ion, I told you guys that the total charge is basically the sum of the charges, right? So it has to be plus 12 and it has to be minus 14 to give you a net charge of minus 12. And I can divide by the number of atoms that are there to get the charge on each atom. That's going to be plus 6, right? Which method is used to prepare a pure and a dry sample, right? Pure and dry sample of lead chloride, right? Mix aqueous lead nitrate with dilute hydrochloric acid, right? Filter, crystallize, and try the filtrate, right? Keep in mind that the nitrates are more reactive, right? And hydrogen. So I don't think lead is slightly bit more reactive than this, right? So we'll think about this. I'm not sure, right? Mix aqueous nitrate and dilute hydrochloric acid. Lead nitrate and dilute hydrochloric acid, filter and wash. Now keep in mind, lead chloride is insoluble, right? This is what they're not telling you, that the chlorides of lead, mercury, and silver are not soluble. If you remember the solubility chart I sent you, right? The solubility rules that I sent you over there, I said if you memorize them, these kind of questions become easier. We have to wash, dry the residue. That is making sense. I cannot crystallize this because this is not a soluble one, right? It's an insoluble salt, right? So now I know that one is wrong, right? So this is still plausible. I'm putting a tick. I'm not marking the option yet. Mix solid lead hydroxide and aqueous sodium chloride. Now keep in mind, chlorine is more reactive and sodium is more reactive. Why would this react with this? So this will have no reaction, right? Immediately, because in the precedence chart, if you remember, sulfate, nitrate, carbonate, right? These ions, OH comes at the bottom, right? Then comes the halide, right? Cl, Br, and I, if you remember, and then comes this OH. So why would the OH replace chlorine over here to react with sodium? Sodium is reactive and chlorine is more reactive. I've stated several times. Then the reactive ones stay together and the less reactive ones stay together, right? So why would the reactive ones will break off and react with this? So there's no reaction, not our option, right? Mix solid lead hydroxide and aqueous sodium chloride, filter, again not a reaction, not possible. So B is our only option, right? Again, this is the same reaction, so we don't need to see about the other stuff. First, the reaction is not possible, right? Here, wash and dry the residue because it is insoluble, right? Again, the solubility chart is given in your book, as well as I've said to you. Memorizing this will help you crack this kind of a question, right? Okay. Phosphorus is an element in group 5 of the periodic table, right? It burns in air to form an oxide that dissolves in water to form a soluble solution of pH 1. pH 1 means it's forming a strong acid, right? Which is phosphoric acid, H3PO4, right? Phosphoric acid. I told you have just 4 acids to remember: phosphoric acid, sulfuric acid, hydrochloric acid. I mean the bromine and the iodine included, right? The halogen acids and the carbonic acid, right? H2CO3 and then HNO3, right? Just the 5 major acids that you need to know, right? Okay. Which row describes this oxide of phosphorus, right? Uh, it is a metal oxide? Not at all. Phosphorus is non-metal. So option A, B are already removed, right? Sorry. Yeah, right. So option A is B removed. Non-metallic oxide, that is correct. So we are stuck with C and D. Acidic oxide, right? It is an acidic oxide. Yes, it is. And is it a basic oxide? No, because if it were an basic oxide, why would the pH go higher, right? So our option is basically C. This is correct. This is not correct, right? So we're just gonna simply omit this. So these are the only two things correct in there, right? So C is our option. It is an acidic oxide, right? Remember, oxides of non-metals are mostly acidic and the oxides of metals are mostly basic, right? Again, the same solubility and the acid base chapter notes that I've given you, it has those statements in there, right? If you read it. The equations, the equation shows the reaction between aqueous hydrogen bromide, HBr, and ammonia, NH3. Remember, acid and base reaction, right? So it's a this reaction. Which statement describes the role of aqueous hydrogen bromide, right? As a catalyst? No. Reducing agent? We'll see. Proton acceptor? No. Acids are not proton acceptors, they are proton donors, right? So this is a plausible option. Now I'm stuck with B because I still do not understand B. So let's look at the charges now, right? I'm not sure about B. So if you look at this, then Br has actually gained an electron, right, from Br, right? This is H positive and minus. If I see that the Br has not changed any state, so there is no electron exchange. It has only given an ion, but there is no electron exchange. So this is not a redox reaction. It is basically a neutralization reaction, right? So this is also gone. So D is our option, right? It's a proton acceptor, proton donor, right? It donated this, right? So HBr in water will give you H positive plus Br negative, hence we call it an acid, right? Proton donors. Arrhenius concept, right? Again, the acid base sheet that I've sent you, right? Which statement about the elements in group 1 is correct? Hydrogen is produced when group 1 elements react with water, right? that is correct, plausible, right? Because if I take sodium and react it with water, it's gonna form sodium hydroxide, and obviously we'll see some bubbling and splashing, coming out. Ions of group 1 element have -1 charge, not possible. They are metals, so they will always have positive charge. Sodium is more reactive than potassium, not possible. Sodium is on top, potassium is bottom, so reactivity increases down the group. Potassium is more reactive, right? Uh, so solid sodium is a poor electrical conductor, not possible. All metals are good conductors, so A is our answer, right? Again, even knowing the answer, I still eliminate all the options, right? Which row describes the color and state of iodine at room temperature and pressure, right? So at room temperature, it is going to be a solid, because you need to remember these ones, right? The Br2, the Cl2, even the F2 I've given you, right? That is white, right? That is pale greenish gas, right? White means colorless, or we call it, right, colorless, or this. And greenish gas, yellowish green, and this is brownish gas, right, as gas. And iodine is purplish fumes, right, purplish they give. So solid would be room temperature because it's very heavy, and it's going to be purple, so C, right? It is just a fact or memory question, right? So nothing to eliminate over here. Green, gray black solid. Oh, sorry, by the way, we're going to call it gray black, otherwise Dania will have objections with me. So they had gray black. Sorry, I will go with gray black, right? The fumes, I was saying over here, fumes, right? So the fumes are purplish. Since it is solid, so solid should be gray black. So I think Dania corrected me on this once, right? Very well, Dania, right? Okay. Part 25, right? The periodic table is given to you, right, over here. So if you look at the periodic table, the part of the periodic table is shown which element is an inert gas. A, B, C, D. The last one is C, right? Okay, four different metals are separately added to water. The oxide of each metal is heated with carbon, right? Four different metals are separately added to water, right? Oxides of each metal is separately heated with carbon. The results are shown, right? So keep in mind, we have no reaction with water. These are oxides of the metal, which are like metal oxide with carbon, right? Brown solid forms, right? That means metal oxide is, when you heat it with carbon and a brown is forming, that means something is forming, right? New product is forming. R, right? If you have this water. Now keep in mind, whenever you put a metal oxide in water, what does it give you? Metal hydroxide, right? And metal hydroxide in water, right, reacting with carbon, right? So it will only react when something is less reactive than carbon, right? Less reactive than carbon. And if you remember the reactivity series, iron, iron, silver, and gold, right? These come underneath it, and zinc as well, right? And then we have aluminum, magnesium, and all that going up, right? So below carbon. So remember the reactivity series over here, right? The order of reactivity of the four metals and least reactive. I think this is the great breaker question, right? It's a star question in the whole paper, the most difficult one, right? So no reaction, right? We don't see any reaction. That means the metal is most reactive. That is why it is not reactive with carbon at all, right? It's not doing anything with carbon. Rapid fizzing means this is least reactive, right? Least, keep in mind, this is trying to trick you into doing so. We are not reacting metals, we are reacting oxides of each metal. Keep in mind that these are oxides of the metal, not the metals themselves, right? So oxides will only react with carbon when something is less reactive than carbon. Only then the carbon will react and reduce the metal for you, right? You get the idea, then solid or liquid, whatever way, and this is going to be forming as a gas. So this is, you can say, kind of the blast furnace, right? So remember, in the blast furnace, only those metals can be achieved or extracted which are less reactive than metal. Those which are more reactive than carbon, they show no reaction and they require electrolysis, right? So rapid fizzing means this is the least one, and the no reaction means this is the most reactive one. That is why it's not reacting with anything, right? So metal oxide, sorry, my bad, I did not read the question properly here, right? Okay, sorry. Again, my bad. This is metal with water and metal oxide with carbon. Sorry, my bad. Right? It does not react with this, and brown solid forms. Right? That is one thing. I think this is somewhere around iron. No reaction with water, least reactive. Sorry, my apologies again. I did not read these. Right? Okay. Or rapid fizzing. That is gonna be most reactive metal, right? Most reactive metal out of them. Few bubbles and few bubbles. For this, we'll have to look into this, right? No reaction uh, of this carbon. That means this is more reactive, right? Now comes our play over here, right? More reactive. Okay, so rapid fizzing and this gray solid forms. That means that the carbon is able to react with it upon heating, right? When we heat it up. So I think the order is going to be no reaction with metal. Q is going to be the last, right? So Q is going to be last. So A, B are crossed out, and out of these, R is the first one. So C and D, right? And out of S and T, we are going to see few bubbles and gray solid forming. That means the carbon is reacting, and carbon will not react with the more reactive one. So S will come first, right? So it would be R, S, T, and then Q, right? R, S, T, Q. C is our option, right? Clear? My apologies. I misread this question initially, right? I was just thinking metal oxide with water and metal with carbon dioxide. Okay, so my apologies again. Okay, happens. As I said, this is a star breaker question. These are the questions that actually make the students go crazy, right? They provide so much information that it actually becomes very hard to read all the information in one go, especially when you're doing a quick run, right? An iron nail is fully covered with zinc, preventing it from rusting. Which road describes this method of protection? Explain why zinc is used to protect iron nail. Right, the method of protection: barrier method and sacrificial protection. Sacrificial protection only, right? It is fully covered. Remember, there are two things. It is fully covered, so it is giving you a barrier method as well, right? And it is giving you zinc as well, so it will do both the things, right? So it is barrier, right? It is physically protecting it, as well as zinc is more reactive, so A over here, right? Keep in mind, it can do both for you, right? Not necessarily with rusting. Let's say if acid drops in, then the full coverage is also protecting you, right? So both of these things are there, right? Okay. Next one. Iron is extracted from hematite in the blast furnace. Which reaction increases the temperature in the blast furnace over 1500 degrees Celsius? Calcium carbonate reacts with this to give calcium carbon dioxide and calcium oxide. No. Calcium oxide with silicate forms calcium silicate. Not at all. Carbon plus oxygen gives us carbon dioxide. Carbon dioxide plus this gives us carbon. I think it's the carbon with the oxygen that gives us the most temperature. This is the only most exothermic reaction. This is endothermic. I think these two are endothermic because this is carbonate decomposition. Decomposition needs heat to break something down, right? So C is our only viable option here, right? That will increase, which is burning of coal. I mean, this is coal, right? Technically speaking. So coal, when obviously burn, it releases a lot of heat, right? Aluminum is extracted by electrolysis of purified bauxite, right? Purified bauxite, which shows the half equations at the electrodes and explain why one of the electrodes has been replaced regularly, right? Now, keep in mind, I'm not gonna start with this one. They gave me an idea to look for to narrow my options down, right? Cathode replace as it gets coated with aluminum, no and no. So I'm only left with option B and C, right? Why? Because it reacts with oxygen, right? And since cathode is the anode is the positive one, so the aluminum will go to the cathode, right? Sorry, right, to the negative one, and the O2 minus will go to the positive one, right? And then from there it will react with the electrode to produce carbon dioxide. Hence, it needs replacement. And this is basically this is the anode and this is the cathode. I just need to get the reactions in the correct order. So at anode, the aluminum is getting there, right? Not at all. So B option is there, right? So at anode, the oxygen is gonna go towards the positive, and at cathode, which is the negative electrode, aluminum will go and get deposit. So this is incorrect. We got to the option, right? Next, Which flowchart describes the correct treatment sequence of the domestic water supply, right? Domestic water supply. So remember, we do sedimentation first. We stop bigger particles, then we filter the smaller particles, and then we add chlorination, right? I told you that the one that they're given in the book and the one that they're given in the paper are entirely different, right? So sedimentation, filtration, and this, right? This is for large particles, this is for small particles, and that's for bacteria, right? If you remember. So again, this is a fact one, just a memory question, right? Okay, there are about like 30% memory questions in there, right? Which statement about oxides of nitrogen are correct, right? They are made in car engines by incomplete combustion of gasoline at high temperature, right? Incomplete combustion, you can say so, right? They are made in car engine when nitrogen in gasoline, there is no nitrogen in gasoline, right? It's a hydrocarbon, so that's wrong, right? They are removed from car exhaust by catalytic converter to form nitrogen and sulfur dioxide. Why would we produce sulfur dioxide, an acidic gas, right? So this is a wrong use for catalytic converter, right? They are removed from car exhaust when they react with carbon monoxide in the catalytic converters, right? So basically what we do is that carbon monoxide with nitrogen reacts with this, right? So this is again, I think this is also wrong. What we do is that we give more of the oxygen to this. So carbon monoxide reacts with this NO2 to give you this, right? So they react with carbon monoxide in the catalytic converter, removed. That is kind of plausible, right? They are made in the car engines in incomplete combustion. No, I don't think has incomplete combustion has anything to do, because if you remember, I told you the nitrogen is coming from air, right? It is part of the air intake of the vehicle, so has nothing to do with it. It just simply reacts with oxygen to give you nitrogen oxide, NO and NO2, and both of them we use to react with incomplete combustion of fuel, right? So the fuel, if there is incomplete combustion, has everything to do with carbon monoxide, has nothing to do with nitrogen. So even this one is wrong, which felt very correct, but still it's wrong. So I'm just going to pick off D over here, right? The alkenes are homologous series, right? Which statement about the members of homologous series of alkenes is correct? They have the same functional group, plausible. They have the same relative molecular mass. No, how? Why would that be, right? They have different chemical properties, not at all. Same functional group means same properties. They have different general formulae, not at all. So plausible one is the only answer here, right? Next, the diagram represents two processes X, Y, and their effect Z, right? In increasing global warming, right? Increasing global warming. So that means this is CO2, right? If that is this, right? Emission of thermal energy from the earth, right? Emission of thermal energy from the earth does this and does this and does this, right? Okay. What is X? Absorption of thermal energy by greenhouse gases, maybe, right? Okay, emission of thermal houses, absorption of thermal energy uh, by greenhouse gases. Yes, they absorb, they don't emit. So the emission is out of the question anyway, right? So option B and D are already gone, right? Now let's check Y, right? Emission of thermal energy to the earth, right? Once they absorb it, they re-emit this, right? Keep in mind the sunlight that comes in gets reflected off, but that gets reabsorbed and gets back onto the surface rather than going out. It should have gone out, but the greenhouse gases, right? They absorb it and re-emit this, right? So emission of thermal energy to the earth, they do so and reduce the thermal energy lost to space. That is technically right, because we need more this to make it go out. So A is our correct option. Even this is wrong, right? This is correct, this is correct, 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 right? So I simply eliminated that these three are correct order. So X, Y, Z is what they're stating over here, right? I thought that this was going to be this, right? Keep in mind, I haven't done this paper before, right? This is the first time I'm doing this 25 paper. I've only done up to 24 papers. 25 paper, I didn't get the chance to have a look at it. Okay. Which structures are structural isomers of each other? Structural isomers of each other. 1, 2, 3, 4. 1, 2, 3, 4. Right? This is not a structural isomer. Keep in mind, I told you the chain can bend around. So it's still a straight chain, right? Nothing different. So 1 and 2 are not structural isomers of each other. Keep in mind, they are not, right? Number 4, again, it is just a bend of a chain. Bending chains are not structural isomers. I can make it like this as well, right? So doesn't matter. It's, I think this one is attached as a single carbon. This is gonna be butane, right? This is also butane, if you note the name, and this is also butane. This is the only one I'm going to call as 1 methyl propane, right? Which is now an isomer because this is also C4H10, and these all are C4. So same molecular formula but different structure. So only 1 and 3 are isomers. Keep in mind, bending of the chain does not count as an isomer until unless there's an actual functional group attached over here, which is this one, right? This is attached as a methyl over here, right? This will count as a methyl because the base chain is the straight chain or the chain which has the maximum carbon atoms, right? So keep in mind, no matter which way I measure this, let's say if I take this as the central chain, right? 3 carbon atoms in one go, then the other one is acting as a functional group. If I take this as the function, then this one is a functional group, right? And even if I take this one, right, this one as a chain, then this is acting as a functional group. So in this one, only 3 are in one line. The others are, the other part is basically the functional group here, right? So it's just 1 and 3 which are structural isomers. Different structures, same molecular formula, right? Rest are not structural isomers, they're just different orientations, right? Orientations don't count, okay? The structure of an ester is shown. Here's the ester link, right? Name the ester. Again, the ester name comes from the alcohol part first, which is without the double bond, and the double bond one is basically the acid part. So this is the acid part, and this is the ethanol part, or alcohol part, right? So we name the alcohol first. So since this is 1 carbon, it is going to be methyl. So this and this are already gone, right? And secondly, we have 1, 2, and 3 carbons over here. So this is gonna be a prop, and this is gonna be a meth, right? So methyl propanoate is our answer. Ethanoate is not gonna be it. Clarified? Next, number 36, right? Which row shows the products obtained by cracking of a large alkane, right? Cracking of a large alkane. Remember, which products are formed? We do get an alkene, we may get hydrogen. Why we would get water? Because we're breaking down an alkane, there is no oxygen, right? So the one with the water are already gone. That's our answer, right? You get the idea? No need to worry about this one. Why would the water be formed? It is just a hydrocarbon that we're breaking. There is no oxygen. Water needs oxygen, right? So very clear answer there. Okay. Tick means that is possible, right? So water is not possible. So the cross one is the only correct one, right? They made it too simple, right? Ethanol is produced by fermentation. I told you this is a very picky question. Was repeated in 24, 23, and 22 papers, right? The fermentation and the advantage and disadvantage, right? So which row shows the advantage, disadvantage of the processes, right? Fermentation of aqueous glucose. Fast reaction, no. Fermentation is slow, right? So option A is gone, right? Either one of them. Uh, Disadvantage, slow reaction. Ethanol is produced in batches, correct? Correct. Catalytic addition of steam. In other words, the industrial process, right? Fast reaction, good. Produce. I think B is our answer, but I'll still check, right? Renewable material, correct. Ethanol produced in batches, correct. Almost pure ethanol is formed. That is correct. Slow reaction, no. It's an extremely fast reaction, so C is gone, right? Renewable material, dilute aqueous ethanol is produced. That is correct. Fast reaction, non-renewable. Dilute ethanol, no, it's not dilute. Basically, we get a mix. It's not dilute. We will say it is a mixture of different alcohols, right? So this gives it away. I think the only one, this is also correct, right? They are non-renewable. So I think B is the only one, right? Ethanol produced in batches, we get small batches of, like, this is called brewing, right? Brewing versus the industrial one. It is a slow reaction, catalytic is fast, and ethanol is produced continuously, right? So you get constant production because you're filling in a gas, right? So you put in the gas, you give it the catalytic conversion, you get ethanol droplets consistently. Okay. Next, the propanoic acid is an organic compound that is both an alkene and a carboxylic acid, right? It's an alkene and a carboxylic acid. Okay. Which structure represents one repeat unit? of this. Now remember, for this to become repeat unit, I told you to immediately draw this as a reoriented one, right? So the hydrogen goes up, the hydrogen goes down. Remember, one hydrogen is on top, then the acid group will come down, right? So if you repeat this, there is no CH3 involved in here, right? So this is wrong immediately, right? If you look at this one, the acid cannot become part of the state chain because the addition polymer requires the double bond to react, not these acid parts, right? So this is going to be extended on both sides, not the acid. So this is also gone, right? If you look at this, we don't have a CH3 over here. Again, this is wrong. So B is our only option for this to become a polymer chain, right? Okay, Meetup, I do have a record. If you went through the recording, we did this in a lot of practice, right? When you were not available, I'll upload the second video as well, right? But that's a small video. We did few questions that back then, right? Which item of apparatus used to measure this much of dilute hydrochloric acid? Now keep in mind it is 0.1, right? So conical flask. Why would the conical flask would be used? Volumetric, that means it's a fixed volume. It cannot take decimal values. That's wrong. A balance, why would we use a balance for volume? So burette is the only one, right? And burette can measure up to 0.1 centimeter cube, right? The others cannot. This has higher you can say precision as well. Chromatography is used to separate and analyze mixtures of soluble substances, right? Soluble substances. The first step of this process are listed. Apply samples to the baseline, develop the chromatogram in solvent, right? What is the next step in process to detect the soluble colorless ones? I told you for colorless, we haven't done this though, right? For colorless, we use a suitable locating agent, right? This is a sheer question that comes in P2 or P6, right? It's a must question. They always ask this question, right? So remember, for colorless substances to be done in chromatography, chromato means color. So colored substances can be easily separated, but what about the non-colored ones? So we add a locating agent which will give them unique colors, right? So that we can trace them, right? Otherwise, what would you get to see on a transparent sheet? I mean, on a white sheet with transparent colors on it, right? You won't get any trace on it. So until unless you put a locating agent, the locating agent will give you colors that this one went this much and the other one went a little higher, right? Otherwise, you won't be able to tell how much. Only you'll see the solvent going up, right? A solvent line was there, but to identify how much which one rises is this one, right? So they're saying calculate the RF values. We can't do that first, right? Compare the result. We can't do that. Count the number of spots. How can you do that when you're not looking at the spots? The spots are not visible at all. So you have to use the locating agent first. Then counting the spots does not really have any effect. We calculate the RF value and then compare the results. Clarified? So the step C has nothing to do with it, right? Chromatography, we don't count anything. We actually measure them. All right. Any troubles?